Hello everyone, welcome to the course on electromagnetic theory and interference. In this session, we will discuss about plane waves and good conductors. A good conductor or a perfect conductor is a one where the conductivity is very large compared to the term omega epsilon, so that sigma by omega epsilon is very large compared to 1. That means conductivity is approximately equal to infinity in case of good conductor. Permittivity is equal to free space permittivity. Permeability depends on the free space value as well as the relative permeability. So if you substitute sigma by omega epsilon is very large compared to 1, I can neglect the 1 and this plus 1 and minus 1 here. So what my answer will become that is omega epsilon by 2 into sigma by omega epsilon. I have taken the root also. So epsilon get cancelled, and if I take the omega inside, what will happen? 1 omega and this omega square will come if I take inside. So we get the answer omega mu, okay, sigma divided by 2. And the phase constant beta also turns out to be same. In case of good conductor, alpha, beta both are having the same value. If I substitute for omega 2 pi f, so 2 and 2 I get cancelled, pi f mu sigma. What about the velocity of wave? It is equal to omega by beta. So if you substitute beta value here in this place, we will get root of 2 omega by mu epsilon as the answer. Whereas the wavelength remains the same, it's 2 pi by lambda. For intrinsic impedance of the medium, if we substitute sigma is very large, so I neglect this term. So I get a j omega mu by sigma. So if I want to write as a magnitude and phase, this root j, what can I usually, j is that means I can write 90-degree phase shift. If there is root j, I have to divide that 90-degree by 2. So 45-degree angle. What that implies, electric field is leading the magnetic field by 45-degree. So we applied the conductivity is very large, okay, compared to omega epsilon in alpha, beta, and intrinsic impedance values, and we've found the expressions in case of good conductors. So we can finally write the expression for electric field and magnetic field. For electric field, it is E naught e power minus alpha z cos of omega t minus beta z into ax unit vector, because electric field is propagating along the x direction. Electric field has a component along the x direction, but wave is traveling in positive z direction. So that is mentioned here. Similarly, for magnetic field, it is, I can write in terms of E naught by eta. Eta, I'm taking the value from the previous thing. Root of omega mu by sigma, same e power minus alpha z cos omega t minus beta z will be there. But the phase delay of minus 45 degrees coming here, because in denominator 45 will be there. If it goes to numerator, it is minus 45 degree, and it has a component along the y-axis, so ay unit vector. As we can see, electric field or magnetic field, both when they are traveling in a conductive medium, its amplitude is getting attenuated by the factor of e power minus alpha. We are going to find a distance called skin depth. So skin depth means it is represented by del. The distance del through which the wave amplitude is decreased, okay, by a factor of e power minus 1 or 37% of this original value. How much it is decreasing, that distance is called skin depth or penetration depth of medium. So del is nothing but it is equal to 1 by attenuation coefficient. So this, by using the skin, we can measure the depth to which electromagnetic wave can penetrate. How much depth the electromagnetic wave can penetrate the medium. And the skin depth we can directly take from 1 by alpha, since alpha is equal to root of pi f mu sigma. So it is 1 divided by that. Because of the skin depth, there is a phenomena called skin effect. So the phenomena where electric field intensity in a conductor rapidly decreases. So it's called skin effect. Because of that, the charges try to migrate from the bulk of the conducting medium to the surface, where we can see high resistance in the very thin layer. Okay, the field and associated currents are confined to this layer. All of the current in the we can observe from this table. Okay, as frequency increases, there is a decrease in skin depth value. Okay, that we can see from this expression also. Del is equal to 1 divided by root of frequency, right? As the frequency increases, the skin depth decreases. So this is an important point to note. So let us see the, because of the skin effect, we will see about the skin resistance and AC resistance in the next session. Thank you everyone. Happy learning.